Arthur and Tom, welcome. Tom's the founder of Geometry, which is, according to my notes, a new research house leveraging deep mathematics, cryptography, and engineering to advance the state of Web3. He knows all about building stuff, as does Arthur. Off you go.
Thank you very much. Well, Arthur, welcome, and thank you very much for coming to CogX.
Thank you for having me.
I thought we've got quite a lot of ground to cover, and I think we've got 35 minutes in which to do it. So the first thing I thought we'd cover is the state of Tezos today. You've obviously had a very active 2021 and start to 2022. We're speaking as the cold wind of a crypto winter is blowing over us, and but I wanted to hear what you've been up to at Tezos recently.
Yes, thank you. So, Tezos is a product that started in 2014, very early on. We were one of the first major blockchain to launch with proof of stake in 2018. And for the first few years, it was a lot of building the toolings, whether it's libraries or programming languages. But you're building a little bit in a vacuum because it's so new. And for us, 2021 is when the rubber really hit the road and people started really using the blockchain. And we saw a tremendous rise in number of transactions on the chain, smart contract calls. So it's actually an actual stress test on the chain. Can you actually work under load? And it did. So that's been great to see, and we've been able to upgrade also during the past few years with an improvement to the consensus algorithm. We've been able to stay ahead of the demand for transactions by having several upgrades that increase the transaction throughput of the chain. So that's been fantastic to see, and it's also so much. I think it's so much pleasure to see people using the chain and finding themselves. A lot of the growth has been driven by the art scene in the NFT markets, and I think it's fabulous to see this type of application thrive on blockchains.
Now, if we can just talk a little bit about what distinguishes Tezos as an infrastructure, as a technology, from some of its peers. It'd be great to hear in particular, how does the ledger update, and how is that a little bit different to what goes on other blockchain networks?
Yeah. So I would say that often there's three pillars, and I'll save the most important one for last. The first pillar is the virtual machine that we use in Tezos. It's a high-level virtual machine. So if you want to write secure smart contract, you'll have an easier time doing this on Tezos than you might have on other blockchains. I think for a long time people have ignored smart contract risk. It went through a phase early on when people thought it would be a big issue, and then we go through crazy phases where you see hacks for $800 million and no one cares. But at some point, I think when the use cases become more real, people start looking at this and it starts mattering. And we've seen people go to Tezos because they like the development environment that we've built here. The second aspect is proof of stake. Some people talk about it. We've been doing it, walking the walk since 2018. And the third and probably most important aspect is the governance aspect. So there's not a central point of decision for how the network upgrades, or there's not a central point of cloud to decide what a hard fork should be. All upgrades on the blockchain are voted upon by the Tezos community of validators. And we originally have quorum in excess of 60%. There are high thresholds for approval, which are of over 80%. And despite these very, very stringent criterions for voting, we've had over 10 successful upgrades on the Tezos blockchain. So it's I would say the governance is a key piece.
So could I ask you, as people are starting to think maybe a little bit more carefully about the economics that run through various levels of the technology infrastructure, particularly in Web3, to be a successful layer one, is the game for a layer one network? Do you have to build a sort of a native asset? Do you have to host a native asset on your blockchain that has candidacy as a macro asset, as a store of value asset? In other words, is that what is going to actually separate the long-term financial security of the layer ones that succeed from those that fail?
I think that's a great question, and I would say most people in the industry are going to fall on a spectrum on that matter. And I've changed my position a bit, but I'm still very much, almost at the extreme end of, yes, you absolutely have to be a macro asset. So the reason why you might have to be a macro asset is in order for your decentralized blockchain to have the economic incentives it needs to secure itself, the assets need to have some form of value in the first place. And where does that value come from? It could come from being a store of value, and that's been successfully demonstrated by Bitcoin, but also by a lot of other assets. It's weird, but the reason I think people still own Litecoin today, for example, is it's still treated as a store of value. It may not necessarily be a very good one, but it is one. And I still think that's how a lot of the market is priced. The second way you can do it is by maybe collecting fees. So especially in proof of stake, holding a token gives you the right to create blocks. Block space is scarce. People want to compete for block space to pay fees and transactions. So if a token will allow you to collect fees from the network, then you have here some economic value. The reason this may be limited is that all of this work is open source. All of this work can be cloned, can be forked. So that puts at the very minimum a limit on the type of rents that can be extracted by those tokens. Because if your token is extracting this rent, what prevents someone from having some of the version of it? And the answer typically is network effect. But network effect in an environment where things are so frictionless, especially with smart contracts, is a little tougher to establish.
So I guess network effects can accrue in several ways, as you've outlined. One is you've got the macro asset, and the other is that you get to collect a sort of a P&L, I guess, classically it would have been called, but I get to sort of make some marginal revenue over my marginal cost that is is a positive spread.
Yeah, exactly, because the marginal cost of actually validating a blockchain is very low, right? And so the only way you can extract something and beyond that is if somehow you have some network effect, you have some position where people are not going to see the competitors that underprice you. And there's two ways this can happen. So I think we're going to see a lot of blockchains scale in the next year, and certainly it's a big focus for Tezos. But as blockchain scales, the first thing that happens is you get more capacity, you start collecting more fees, because right now there's a lot of constraints and there's a lot of demand for cheaper transaction fees. So at first it's great, your fees are lower, but you get more transaction, you collect more fee volume in total. Fantastic. And then as you increase the capacity, all of a sudden the price can decrease faster than the capacity increases, and you might end up with the product of your number of transactions times your fees actually going down. The counter argument to that is that by that time the fees are so low that people are going to be insensitive to the price. A good example is if I ask you, how much is a kilogram of salt? You probably don't know on top of your hand how much is a kilogram of salt, because even though you buy it in the supermarkets, it's such a small part of your budget that you don't really care about it. So hopefully we get to a point like this in the blockchain space, but that requires that there's a very large demand for transaction that's latent. Like people really want to use a very, very large amount of transaction. If that's the case, then maybe you can sell trillions of transactions for fractions of a penny, right, and you extract a lot. But it's still unproven.
And I suppose then the other question here is, what is that rent if it can be extracted? So let's run the hypothesis, I suppose, that it can be extracted. Who's it being extracted on behalf of? Because I suppose a lot of these networks, they exist on behalf of their engineers, their users, and that's not always the same collection of people as the token owners. Could that cause sort of economic frictions, economic sort of wars over time if the kind of the marginal, essentially the marginal revenue per transaction is so far in excess of the cost that ends up being sort of infinitely corroded away?
Well, ultimately what happens on a blockchain is determined by what's inside the block. That's almost triviality. Yeah. And so whatever value is being captured is going to be captured by people who can decide what go inside the block. That, I think, is very straightforward. I mean, you can still build some other network effects, maybe some smart contract application which has a token, is able to capture some network effect, which is not necessarily immediately extracted by the block producers, but by and large in an L1, the people who produce the block. And with scaling solutions, we're going to see a lot of decoupling between the different functions. So they're not necessarily the people maintaining the data, they're not necessarily the people doing the computation, but the people who decide what order transactions go in are the ones who are going to capture the data. And that, I think, is true even if you build layer 2 solutions, because those layer 2 solutions still have to include their transactions as settlement inside of this layer. So ultimately, a lot of the data is captured here.
So I guess this is maybe a good opportunity to move on to the scaling side of the industry, and in particular, should we maybe talk first about the technology that's been driving a lot of this scaling, and how you see that, and also what you're building at Tezos to scale your own network?
So it's funny because for the longest time, people were even talk about scaling as something that was impossible, a pipe dream, castles in the sky. And it's true that most scaling schemes didn't really make sense. They were very, very cumbersome. They had a lot of complexity. And I think over the past year and a half, we've started seeing scaling schemes that actually are sensible, tractable, and can be built. But people are still in the mindset that transactions are scarce, it's going to be so hard to scale. And I don't think that's the case anymore. The general technical idea, I would say, behind the scaling solutions is that if you look at a traditional layer 1 blockchain, there's a few functions that are being done by the block producers. They order the transaction, they make the data available for people who join the network, they execute the transaction and look at the content, they maintain the state of the ledger. So they do all of these things. And the secret, in some sense, to scaling is to disentangle all this function and to give different actors different roles. And if you do that, you can still maintain the security that you have, while at the same time increasing the throughput in proportion to the number of participants in the network, which is really the secret to scaling. And it's been a very, very big focus in the Tezos ecosystem. There's a hub in London called Trilitech, which has been working a lot on scaling solutions. So the type of approach that we're taking is a combination of building a data availability sampling solution. So essentially, instead of everyone downloading every block, you have everyone downloads little fractions of every block using error correcting code. It's becoming almost a standard solution now. And for execution, a technique called optimistic rollups.
So that's interesting. So you've caught me off guard for a second there. So maybe we can break this down for people so that they kind of understand what it is that a data availability solution functionally means. So when we stare at our blockchain, we need to know a few things. We need to know that we've got the preeminent record of economic events. We need to know that it's internally consistent and correct so that we're staring at the right thing. And then we also need to know what that record actually says. And so I wonder whether we can break down these roles and maybe hypothecate a little bit on who is going to be providing these services 5-10 years into the future. Who's going to be doing this?
It's funny because when you think of the function and the validators of a network do, it's the ones that seem the simplest and almost trivial that are the most complicated. So and the thing is, look, everyone calls it validators. You validate the chain, and actually validating the transaction and executing the transaction is the easiest part to scale. The parts which are hard as part of these networks is not validation. It's things like deciding in which order the transactions are going to go in. It doesn't even sound like this should be a problem, but that is one of the biggest problems. That's why you need consensus. That's why you have majority attacks and all of these problems. That's a very simple problem, deciding in which order they go in. And the other one is data availability, which is to say, if someone joins the network, how do they know what state the network is in? How does they get data on which transaction happened and didn't happen? That almost seems trivial. You'll say, well, yes, they download it. Okay, but from whom? So these are the actual really, really hard problem to scale as opposed to execution. And so the way you do that, I would say, is consensus can scale so long as you're not requiring the nodes who take part in the consensus to download all the transactions. If they start downloading all the transactions, it's already too late. And they can't have to execute all the transactions. So basically what they get is they get these big commitments to bundles of transaction, and they just decide, okay, that bundle goes before that bundle. I'm not exactly sure what's in there, but that's going to be the order that goes in. That's how you do it. And then you have other actors who can specialize in building those bundles of transaction, who have some understanding of what these transactions are, some connections to customers who want to make transactions. And you have parties who merely execute those transactions, get the results, they maintain large states, they potentially have very large computers to doing this execution.
Right. So I guess again, 5-10 years into the future, are we talking about sort of large clusters of sort of AWS style, Google Cloud style companies? Are we talking about smaller, more sort of homegrown collectives of computing power? Is this something that we will all likely be contributing to via our own personal devices, whatever those are, in 5-10 years?
I think ideally you see a mix of two. But what's really important, I think, before you even think about, should these be like big actors or small actors or anything like that, what are we trying to achieve? We're not trying to achieve participation by small actors. That's not a terminal goal, that's an instrumental goal. What we're trying to achieve is security. Now, in the case of consensus, when you need an honest majority, having as large of a set of participants as possible is valuable. And for that, it's a good thing that people who don't have a lot of computing power, who maybe have small devices, can participate in that. But for parts where you don't have to trust the actor, then it doesn't matter if the actor is very, very big. It doesn't matter if you're depending on, I don't know, a Google or an AWS, if what they're doing is proved by cryptography. So it's not so much about who the actor is, but what power do they have over the network, and minimizing that power as much as possible.
Got it.
So I say we see a mix. I say we see like small devices for consensus, and then larger actors for computation.
That makes sense. And so if we zoom out, if you're building let's say a layer 2 today, how do you prepare? So I mean, on Tezos, are you? I presume you're spawning several layer 2s, or there will be several layer 2 scaling solutions.
Yeah. So there's
how do you monetize it? Is really what I'm going to ask. Is what if token don't go up anymore? We'll see.
Yeah.
But if token doesn't go up, then what's how do I build a business around a layer 2?
So a lot of the work on layer 2 is being financed by the Tezos Foundation, which is a non-profit. Mm-hmm. So it's not looking to make a profit out of this layer 2. It's looking to make Tezos great. And so a lot. Obviously, layer 2 solutions are something you can build on any smart contract platform. So someone can come in and build a layer 2 solution for Tezos based on smart contracts. They can build optimistic rollups, CK rollups, whatever you want. But there's a solution that's being built at the protocol level itself. Some people call it enshrined. So it's a facility within the protocol for anyone to easily launch an L2 scaling solution for the Tezos chain. But the goal of it is not that you make money by launching your L2. It's there. It's infrastructure. It's like building a highway. The goal is that you're making money because you have a business of shipping freight between one city and the other, and now there's a highway. Right. So I think of it that way. A lot of people think of infrastructure in this space as somehow like something that's going to earn something. But I'd rather think of infrastructure as a public good that's available to anyone using the network.
Right, and I guess a bit like bridges and roads, these things have to ossify, they have to kind of freeze up over time, which is almost the opposite thing that you do as a company, where you're trying to continually true up your margin by creating more and more innovative products. The protocol section seems to almost go the other direction, because it's now got billions of dollars maybe of assets relying on it.
It's true, and Tezos has been from the start an evolving protocol, trying to basically solve this dilemma of how do we evolve without centralized control. But I would say over time, Tezos is going to converge on some design. Once you have a solution that scales, where people can launch layer 2 solution with even different roles if they want to. At some point, there isn't all that much to solve. At which, and I would say the final stage of governance is when governance becomes only about token issuance. When you decide, do we want to have more coin in circulation, for example? Or do we want to set a floor for fees? That's also a possibility if you want to extract rents with fees and you have enough network effect to afford it. That's one of the things you can do. That's what governance ends up being about once you've converged on a technical solution that kind of satisfies all requirements.
Makes sense. So I'd like to use the last 9.5 minutes to focus on DeFi, and in particular, what I want to sort of get to is maybe towards the punchline, towards the end of the talk, is about some of the work that you've personally been doing, but maybe we can use that as a punchline, and for the moment just look at what we've already done with stablecoins in the last 5 years. I'm of course asking this in the wake of the collapse of Terra, of Luna. So I mean, Arthur, first question is, why do we keep on running this same experiment 5, 6, 7 times? Death loops baked into the middle of algorithmic stablecoins that are operating in adversarial environments and producing arguably deadweight capital. What are we doing here?
There's several things that are going on. First, I think there's a refusal to think from first principles, or rather, people don't want to trust their ability to think from first principles. They're looking at this and they're saying like, well, there's some people who say that works, there's some people that say that don't work. I can't engage with the argument myself, so I'm going to step out and just look at consensus opinion. And I think for most people, it might be fine to look at consensus opinion. What scares me is we see VCs look at consensus opinion, and for me, the job of an investor is to be able to depart from consensus opinion. Otherwise, what's the point? And a lot of VCs in these markets, they have not really been acting as venture capitalists, they've been acting as investment bankers. What they do is that they give bridge financing to a company before they issue a token, then they issue the token, then they sell the token. And so for these people, they will finance those stablecoin projects. It doesn't really matter to them so long as they think there's a good enough story behind it that they're going to be able to sell the token. And that's all that matters. So until such a time where the broad market realizes that, they shouldn't buy into this thing, that, it might keep happening. But I also think there's a reputational angle which should be strong, but isn't in play. So many people in our industry play this as a single-time game. There's basically no reputational cost for doing these things. You do it and then you do it over. And there's some sort of amnesia that happens in a market that's remarkable.
So could we actually go into maybe the machinery of what went wrong with Terra Luna? I mean, I think, for a lot of people who have maybe been studying this for 4 or 5 years, it felt like it had a lot of the hallmarks of things that had gone wrong a long, long time ago. So can you maybe sort of just pull apart the bits of the machinery that were possibly even always bound for failure, and then what's the recipe book? What's the list of ingredients that we need to make a tenable stablecoin that's going to produce useful capital over long periods of time?
Yeah. So the first thing is that there are stablecoins out there who have a design that is worse than Luna. First of all, like there's some unclassified stablecoin, like the basis mechanism, for example, that was quite popular with VCs. There was a ton of money from VCs. I remember being contacted at the time and explaining in a long letter why that wouldn't work. They didn't end up launching, but some version of it launched and of course collapsed. And the idea behind Luna is to say we'll have an elastic supply, right? So we have this kind of cryptocurrencies that exist, and then if people want to mint stablecoin, they can do so by burning some amount of that currency based on whatever the prevailing price is. And if they want to redeem it, then we'll print more. By and large, first of all, there's some issues here. One is that if you do this and you have no mechanism for preventing overextension of your supply of tokens, you'll have a problem because you could extend beyond the equity that's available in your network. So that's a problem. You need a way to control that, and the way to control that usually is through interest rates. So there's no mechanism here. In fact, what they had was an interest rate that incentivize the expansion of the supply as much as possible. But even if you go back just right before the collapse of Luna, you still have, it still looked like the market capitalization of Luna was far in excess of the outstanding supply of UST. But the thing is, of course, as redemptions start happening, the two are very, very linked. Like the value of Luna was seen as very, very tied to the value of UST. So if UST collapses, people see that Luna collapses. So you have some reflexivity happening in this cycle.
So it's kind of, it feels like a little bit if HSBC or some big bank decided that the whole of their balance sheet was just going to be HSBC equity, right? That's maybe a sort of a close and the closest analogy you could think of in the current economy to what they were doing.
The thing that's weird as well, and I think is because the market participants were really mispricing it, is that in theory, right? Let's say you have Luna and someone prints 100 million worth of UST.
Yeah.
Normally, the market, the sum of the market cap of UST, and Luna should stay constant.
Yeah.
But that's not what would happen, because what they would do for this is they would buy up Luna, which would bid up the price of Luna, burn it, and then issue the thing. But in reaction, like, people would not say, oh, the liability, which is UST, has increased, therefore I will sell some Luna because it's overpriced. If anything, they were like, no, it went up. So in a market where things are priced not based on any kind of fundamental, but based on a direction that they've been having in the past week, that's also a recipe for disaster, and that's really a big part of, probably one of the biggest part of the problem here.
Got it. So we've seen what's gone wrong. So maybe two questions to finish. One is, what does a correctly drawn stablecoin look like?
Yeah.
What are we going to see in the asset base of stablecoins? Again, goggles on. We can travel as far into the future as you want. Mm-hmm. But are we going to have crypto as in sort of the bitcoins, the ETHs, the Tezos type assets as the asset sheet here, or is it going to be something else? Or and then can you tell us a little bit also about how Checker addresses this as well?
Well, I mean, you have two routes, and you could say that you're going to collateralize this by crypto assets, which are native to the platform, which has a benefit of minimizing trust. In some sense, you're not relying on a central party, because if someone says, oh, I tokenized gold on a platform, and then you use that as collateral, you're dependent on the person who tokenized it to actually honor redemptions, right? And if you're willing to do that, you might as well use a tokenized bank account, like USDC or USDT, or this type of things, where someone just has we'll have a balance sheet of treasuries and dollars, and that will back it. That's the simplest way to do it. If you don't want to depend on an intermediary like that, then you're going to have to use crypto assets regardless. And the key to make it work, I would say, is one, being cognizant that there's a lot of volatility in those assets, and so that means having very large over-collateralization. Two is you also want to have some limits on the amount that can be outstanding based on the liquidity of the market. So, even if you have a 2x haircut, if the entirety of the supply of a cryptocurrency is backing something, as it reduces, you're going to have a massive price impact. So in fact, the haircut is not just a function of the volatility of the assets, it's a function of the total amount of the assets that is present in the market.
So haircut here meaning if I chop the value of the assets that I'm seeing backing the system by some percentage, the thing is still over-collateralized, it hasn't gone underwater.
Exactly. Yeah. So the haircut is saying, like, look, you have $120 worth of collateral, you have $100 outstanding liability.
Yep.
We're going to call the position. Well, the haircut in this case is $20. So if you do that, your over-collateralization is dependent on total amount of assets, and you have an interest rate mechanism that can balance supply and demand, and that can go negative. It's very important that your interest rate can go negative, because if all of a sudden you have massive demand for your stablecoin, but not that much interest in minting it, then that doesn't work. So if you have all these elements and you process liquidations with careful auctions, you can have something that I think works decently.
And the balance sheet, as in the asset side of the balance sheet, is it always going to be?
If it's not crypto, you might as well just make a USDC type or Gemini dollar type stablecoin.
But what about kind of really long run working capital for businesses that are created as DAOs or that sort of thing? Is that like running the duration game or running the?
Sure, but in that case, it's I think it's isomorphic to a loan in some sense. And if you're building a stable, collateralized algorithmic type stablecoin platform, the code base for that is very, very similar to a lending code base, right?
So swap it out.
You could be borrowing out a tokenized dollar against your tokenized house, for example, and that's very similar mechanics.
Well, Arthur, we've just been timed out. Thank you very much for your time, and pleasure to talk to you.
Likewise.
Thanks.